We solve some more problems in quadratic equations and theory of equations. The next problem, that is problem number 17. If f of x is equal to ax square plus bx plus c has real roots and its coefficients are odd positive integers, that is special thing to be noted, the coefficients, that is a, b, c, are odd positive integers, then first option, f of x equal to 0 always has irrational roots. Second option, modulus of f of p by q is greater than or equal to 1 by q square, where p and q are integers. Third option is, if AC is equal to 1, then equation must have exactly 1 root alpha such that integral part of alpha is minus 1. And fourth option, equation has rational roots. These are the options before us. Let us first note that the given function is, what is the given function? F of x is equal to ax square plus bx plus c. Here a, b, c are all odd positive integers. Let us recall one of the famous results regarding the roots. If the coefficients a, b are all odd positive integers, then such an equation can never have rational roots. It can be proved also. If you take a is equal to some 2n plus 1, b is equal to some 2m plus 1 and c is equal to some 2k plus 1, and if you find the discriminant, it can never be a perfect square. So that equation, that quadratic equation ax square plus bx plus c is equal to 0 with the coefficients a, b, c as odd positive integers can never have rational roots. Here it has been given that it has real roots and the roots are not rational. What does it mean? The two roots must be irrational. Therefore, f of x is equal to 0 always has irrational roots. So first option is correct. Moreover, this is multiple answered question. We have to check another option also. What is the second option? Mod f of p by q. What is mod f of p by q? This is nothing but modulus of a into p by q whole square plus b into p by q plus c. This is equal to modulus of course you can take q square as LCM, ap square plus bpq plus cq square. You see, a, b, c are odd positive integers, p, q are integers, so p square, pq, q square are all integers, and we are considering the absolute value in the numerator. Of course, mod q square is q square. That is why we have not taken absolute value symbol here. Therefore, this is definitely greater than or equal to 1 by q square. Because numerator is greater than or equal to 1, it is greater than or equal to 1 by q square. Therefore, second option is also correct. So, what are the suitable options here? Option A and option B. Both the options are right. The next question before us is, a, b, c are real numbers with a not equal to 0 and alpha, beta are the roots of the equation ax square plus bx plus c is equal to 0. Then one of the roots of the equation a cube x square plus abc x plus c cube is equal to 0 in terms of alpha and beta are. The first option is alpha square by beta, second option is alpha cube, third option is beta cube, and the fourth option, that is option D, is alpha beta square. Let us have a check. What are the given equations? First of all, the first equation is ax square plus bx plus c is equal to 0. And the next equation is a cube x square plus abcx plus c cube is equal to 0. Given that, let me call this 1, this 2. It is given that roots of the first equation 1 are What are they? Alpha, beta. From this we can have alpha plus beta is equal to minus b by a and alpha beta is equal to c by a. This is the data, of course. Let us now concentrate on the required. Which is required? What are the nature of the roots, or rather what are the general form of the roots of the equation a cube x square plus abcx plus c cube is equal to 0. So we want to know about the roots of that equation. Well, let me assume, let gamma delta be the roots of second equation. As we could assume gamma and delta are the roots, we can say what is gamma plus delta? Sum of the roots of this equation. What is that? Minus abc by a cube. If you cancel one a, this is minus bc by a square. Again you can rearrange this as minus b by a into c by a, isn't it? Well, let us trace it. Minus b by a, what is minus b by a? Alpha plus beta. What is c by a? Alpha into beta. What is alpha plus beta into alpha beta? What is alpha plus beta into alpha beta? Alpha square beta plus alpha beta square. This is the sum of the roots. Let us have a look over the options given. You please look at option D. Alpha beta square is also there, and we could have arrived at the scene that gamma plus delta is alpha square beta plus alpha beta square, so that we can notice that alpha beta square is one root and alpha square beta is another root. That is absolute and proper guessing. Therefore, one of the roots is alpha beta square. What is the right option? Option D, that is the fourth option, is the correct option. As we could observe that gamma plus delta is alpha square beta plus alpha beta square, we could have arrived at it. And it can be made clear if you want, even if you consider gamma delta. What is gamma delta? C cube by a cube. C cube by a cube. That can also be taken as alpha square beta into alpha beta square is nothing but alpha cube beta cube. What I mean to say is, we have found gamma plus delta like this. Now you find gamma delta. What is gamma delta? C cube by a cube. This is c by a whole cube. This is alpha beta whole cube. This is again alpha beta square into alpha square beta. By looking at these two results, we believe, we notice, we find that the two roots are alpha beta square and alpha square beta for the given equation, that is a cube x square plus abcx plus c cube is equal to 0. So, one of the roots of the given equation in terms of alpha and beta is alpha beta square. That is the fourth option. Option D is the right option. Let us get ready to look at the next question. That is question number 19. There are two numbers which are such that their sum multiplied by the sum of their squares is 5500 and their difference multiplied by the difference of their squares is 352. Then the numbers are, he has given four options. The first option is prime numbers only, odd positive integers. Option C is prime but not odd, odd but not prime, odd but not prime. These are the options. And in this problem, an algebraic general elementary calculations are involved. Let us study the problem once again. There are two numbers, okay. Let the numbers be x and y. Let the numbers be x comma y. Let us follow the sentence very carefully. Their sum, that is x plus y, multiplied by the sum of their squares, that is x square plus y square, is equal to 5500. 5500 and the difference being multiplied by, the difference means x minus y, either x minus y or y minus x, that is mod x minus y. For the sake of convenience, for the present, let us consider it to be some x minus y into is being multiplied by the difference of the squares. What is that? X square minus y square. Of course, this gives the product. What is the product? 352. 352. If you add them, you'll have x cube plus y cube. If you add them, you have x cube plus y cube, and if you subtract them, you have xy into x plus y. By solving them, you will be able to have x and y very easily. X is equal to 13, y is equal to 9, or x is equal to 9, y is equal to 13. It is an easy calculation. So that, what is the fate of these answers? 13 and 9, are they prime? 13 is prime, but 9 is not prime. They are of course odd. So among the all four options, the second option is a suitable option. Odd positive integers, that sentence is applicable for both the answers 13 and 9. Both are prime is wrong because 9 is not prime. Odd but not prime, but this is odd and prime. So fourth option is also not correct. Prime but not odd, 9 is not prime. So option C is wrong. So what is the suitable option? Odd positive integers, that is option B is the right option. The next question, that is question number 20, is before us. The value of x satisfying the equation x power 4 minus 2 into x into sine of x pi by 2 whole square plus 1 is equal to 0 is first option 1, second option minus 1, third option 0, option D is no value of x. What are the suitable options? What is the suitable value of x that satisfies that equation? Let us first observe the given equation. What is the given equation? X to the power of 4 minus 2 into x into sine of pi by 2 x whole square plus 1 is equal to 0. Is equal to 0. Let us observe this. X to the power of 4 plus 1 is equal to 2x square into sine square pi x by 2. Divide it with x square. What is going to happen? X square plus 1 by x square is equal to 2 into sine square pi x by 2. This is a peculiar equation exhibiting a special character. What is that character? Observe LHS, x square plus 1 by x square. X square plus 1 by x square, x plus 1 by x, a plus 1 by y plus 1 by y, k plus 1 by k. All such things, they have the minimum value 2. As x square is positive, this lies between 2 and infinity. Therefore, this is LHS is greater than or equal to 2 always. LHS is greater than or equal to 2. From the earlier ranges of functions, we can easily notice that x square plus 1 by x square is greater than or equal to 2. In fact, the range is closed interval 2 to infinity. Okay, what happens to the fate of RHS? In RHS, we have sine square pi x by 2 is here. Actually, sine pi x by 2 lies between minus 1 and 1, whereas sine square pi x by 2 lies between 0 and 1. Therefore, 2 sine square pi x by 2, 2 sine square pi x by 2 less than or equal to 2. Therefore, RHS is less than or equal to 2. That is the special phenomenon that can be observed in this equation. Left hand side is greater than or equal to 2. And of course, right hand side is less than or equal to 2. Observe the two quantities, that is greater than or equal to 2 and this is less than or equal to 2. But these two are becoming equal. When can it happen? It can happen when and only when both of them are equal to 2. That's all. Otherwise, this would be a contradiction. Therefore, x square plus 1 by x square is equal to 2 sine square pi x by 2 is equal to 2. Moreover, this is equal to 2 happens when and only when x square is equal to 1. 1 plus 1 by 1 becomes 2. X square is 1. X square is 1 implies x is therefore equal to plus or minus 1. So, x is 1 is the right answer. X is equal to minus 1 is also a right answer. Therefore, what are the right options before us? Option A is correct and option B is also correct. The two right answers are 1 and minus 1. That is option A and option B. The next question is ready for us. If the equation whose roots are the squares of the roots of the cubic x cube minus ax square plus bx minus 1 is equal to 0 is identical with the given cubic equation, then the first option is a and b are the roots of x square plus x plus 2 is equal to 0. Second option is both a is 0 and b is 0. Third option is a is equal to b is equal to 3. Fourth option is a is equal to 0 and b is equal to 3. Let us check the options. Let us observe the given equation. What is the given equation? X cube minus ax square plus bx minus 1 is equal to 0. It is a cubic. Let alpha, beta, gamma be the roots. From this, what can you have? Alpha plus beta plus gamma is equal to minus of minus a by 1, that is a. Alpha beta plus beta gamma plus gamma alpha is equal to b. And alpha beta gamma is equal to minus of minus 1, that is 1. Okay. We need to find that equation whose roots are squares of the roots of this. That is, we are ready to have the equation whose roots are alpha square, beta square and gamma square. So for that, we need to find alpha square plus beta square plus gamma square, alpha square beta square plus beta square gamma square plus gamma square alpha square and alpha square beta square gamma square. Let us now be ready to find all those three. First of all, firstly, what is alpha square plus beta square plus gamma square? You can have this as alpha plus beta plus gamma whole square minus 2 into alpha beta plus beta gamma plus gamma alpha. What is alpha plus beta plus gamma? A square minus 2b. We have got it. Alpha square plus beta square plus gamma square is obtained. And the second one, alpha square plus beta, alpha square beta square plus beta square gamma square plus gamma square alpha square we want to have. This we can obtain it as alpha beta plus beta gamma plus gamma alpha whole square minus 2 alpha beta gamma into alpha plus beta plus gamma. Alpha plus beta plus gamma. What is alpha beta plus beta gamma plus gamma alpha? B square minus 2. Alpha beta gamma is 1. Alpha plus beta plus gamma is a. So it is b square minus 2a. You don't forget these. These are very essential for us. Alpha square beta square plus beta square gamma square alpha square we have found. And the last one, that is alpha square beta square gamma square. It is just nothing but alpha beta gamma whole square, that is equal to 1 square is equal to 1. So the needed things are ready. Let us form the equation whose roots are alpha square plus beta square, alpha square beta square and gamma square. What is that? X cube minus alpha square plus beta square plus gamma square into x square plus alpha square beta square plus beta square gamma square plus gamma square alpha square into x minus alpha beta gamma is equal to 0. That is x cube minus what is alpha square plus beta square plus gamma square? A square minus 2b into x square plus b square minus 2a into x minus 1 is equal to 0. Minus 1 is equal to 0. Now, we now concentrate on the sentence given in the data. The equation whose roots are the squares of the roots of the given cubic is identical with the given cubic. That is, this is the given cubic and this is the equation whose roots are squares of this. From data, these two equations must coincide. So, they're identical. On comparison, what can you have? A square minus 2b is equal to a. Therefore, a square minus 2b is equal to a. Next one, b square minus 2a is equal to b. And the last, minus 1 is equal to minus 1, you need not have this. So, these two are important pieces of information to decide the answer. Let us now make use of this. You can eliminate a or you can eliminate b so that you will have a relation connecting one of those two variables, that is a and b, so that we will be able to decide the options. We are now ready to eliminate, say, b. We eliminate b from these two equations and let us see what is going to happen. Let me call this 1, this 2. First equation implies 2b is equal to a square minus a, or b is equal to a square minus a by 2. Using this, 2 becomes, what is b square? A square minus a by 2 whole square minus 2a is equal to a square minus a by 2. Let me multiply with 4. A square minus a whole square minus 8a is equal to 2 into a square minus a. Right? I have multiplied this with 4. This 4 will go away. 4 into 2 you 8a. 4 into this is 2 into a square minus a. This is a into a minus 1. A square into a minus 1 whole square minus 8a minus 2a into a minus 1 is therefore equal to 0. Let me take a as a common factor. A into a minus 1 whole square minus 8 minus 2 into a minus 1 is equal to 0. I have got a out. Again, this is equal to a into a square minus 2a plus 1 minus 8 minus 2a plus 2 is equal to 0. Again, this is a into a cube minus 2a square plus a minus 8 minus 2a plus 2 is equal to 0. That is a into a cube minus 2a square minus a minus 6 is equal to 0. You can easily observe that a is equal to 3 is a factor, and this can be factorized as a into a minus 3 into a square plus a plus 2 is equal to 0. From which you can say that a is equal to 0 or a is equal to 3 or a square plus a plus 2 is equal to 0. Let us observe these two things. If a is equal to 0, what happens? B is also 0. If a is equal to 3, what happens? 3 square is 9, 9 minus 3 is 6, 6 by 2 is 3. As we could eliminate A, in a similar way we can eliminate B also, so that we can observe that B square plus B plus 2 is equal to 0. Observe these two things. A is 0 or A is 3 or A is a root of x square plus x plus 2 is equal to 0. In a similar fashion, B is 0 or B is equal to 3 or B is a root of x square plus x plus 2 is equal to 0. Hence, what are the correct options? A is equal to 0, B is equal to 0 we have got. So, second option is correct. A is equal to 3, B is equal to 3 we have arrived. Third option is also correct. A is a root of A square plus A plus 2 is equal to 0 and B is also a root of B square plus B plus 2 is equal to 0. That is, both of them are roots of x square plus x plus 2 is equal to 0. So, first option is also right option. So, except the fourth one, all the first three options are right options. Option A is right, option B is right and option C is also right. So, this is a multiple answered question. We could have observed that the first three options are right options. Moreover, this occurs in algebraic simplification also. You must be doing it very carefully so that you will be able to have the answers A, B, C, that is first option, second option and third option also as the correct options. The next question we are going to deal with is a big equation has been given, pi power e by x minus c plus e power pi by x minus pi plus pi power pi plus e power e by x minus pi minus c is equal to 0. And four options have been given regarding the nature of the roots of that given equation. In the first option, there is one real root in the open interval e to pi and the other root is in pi minus a to e open interval. Second option, one real root is in open interval a to pi and the other root is in pi to pi plus e. Option C, two real roots in pi minus e to pi plus e. And the fourth option is there are no real roots at all. Let us see what happens. What is first of all the given equation? Pi power a by x minus e plus e power pi by x minus pi plus pi power pi plus e power e by x minus pi minus e is equal to 0. And this is a somewhat a difficult task to deal with that. Let us multiply on both the sides with the products of this denominator, x minus a into x minus pi into x minus pi minus c. Let us see what happens. Pi power e into x minus pi into x minus pi minus e plus e power pi into x minus e into x minus pi minus e plus pi power pi plus e power e into x minus e into x minus pi is equal to 0. By multiplying this with the product of x minus e into x minus pi into etc. Now let me call this f of x. Let f of x is equal to, clearly it is a quadratic polynomial. X squares and x squares, that's all. That is the largest degree term we observe in f of x. Surely it is a quadratic one. Quadratic, it's a polynomial, so it is continuous also. Let us observe, let us recollect the mean value theorems in continuity. This is a continuous function. Moreover, let us observe what is f of e. F of e, e minus e is 0, e minus e is 0. These two things will go away, leaving you e minus pi into e minus e minus pi into pi power e. Here pi is 3.14 and something, whereas g is 2 point something. This is negative into minus pi, so it is positive. This is positive, therefore this is positive. F of e is positive. And again, let us observe f of pi. What f of pi is? Pi minus pi? 0. Leave it. Pi minus pi? 0. Leave it. Here, pi minus e, that is e power pi into pi minus e into pi minus p is 0 minus e. Pi minus e is positive, e power p is positive, minus e is negative, total negative. What can you observe with this observation? F of e is positive and f of pi is negative. Therefore, from these we say that f of x is equal to 0 has a root in open interval e to pi. If f of a greater than 0, f of b less than 0, or f of a less than 0 or f of b greater than 0, and f is continuous in that interval by a famous mean value theorem in continuity, which is of course called Bolzano's mean value theorem. Yes, by that we say that f of x equal to 0 has a root in open interval e to pi. Open interval e to pi. Well, one root has been obtained. A part of second option is observed correct. A part of that is observed correct. One more thing, f of pi we could have calculated. Now let us calculate f of pi plus e. What should happen? Pi plus e. If x is pi plus e minus of pi plus e, 0. Pi plus e minus of pi plus e, 0. These two will be cancelled. What about the last one? Pi power pi plus e power e into x is pi plus e. Pi plus e minus e is pi. Pi plus e minus p. Pi is e greater than 0. Well, you observe these two. What can you say? F of pi is equal to something. F of pi plus e is negative. This is negative, but this is positive. From these two, we say that f of x is equal to 0 has a root in pi to pi plus 1. Sorry, pi to pi plus e. Pi to pi plus e. Good. Next one. So option B is observed correct. Option B is observed correct. So one real root in open interval e to pi and one real root in pi to pi plus e. Pi to pi plus e. E to pi and pi to pi plus e. One root is there and another root is here. By observing option C, there must be two real roots in pi minus e to pi plus e. What is pi minus e? 3 point something minus 2 point something. This is strictly less than e. Pi minus e is less than e, isn't it? Therefore, as pi minus e is less than e, we say that from pi minus e to pi plus e, there are two roots. How can you say, okay, from e to pi, there is one root. From pi to pi plus e, there is another root. There are from e to pi plus e, there are two roots. But pi minus e is less than e. Therefore, from pi minus e to pi plus e, definitely two roots will be there. Therefore, a summary of the option B is nothing but option C. We can say that both the options B and C are right here. In answering this question, we could have made use of properties of continuous functions. If f of A and f of B are of opposite signs and f is continuous, there is a real root of f of x equal to 0 between A and B. A famous result. Yes, of course. Hence, both options B and C are correct. The next question is, If alpha, beta, gamma are the roots of the equation 9x cube minus 7x plus 6 equal to 0, then the equation x cube plus ax square plus bx plus c is equal to 0 has the roots 3 alpha plus 2, 3 beta plus 2 and 3 gamma plus 2. Where first option, capital A is equal to 6, capital B is equal to minus 5, capital C is equal to 24, and fourth option is A plus B plus C is 23. Let us see. Here, the most convenient factor in the question, the required item is that new equation x cube plus ax square plus bx plus c is equal to 0 has the roots 3 alpha plus 2, 3 beta plus 2, 3 gamma plus 2. They are all of the same form. That is the most convenient form here. Let us now try to get the answer. What is the given equation? 9x cube minus 7x plus 6 is equal to 0. Given that alpha, beta, gamma are the roots of that equation, alpha, beta, gamma are the roots of 1. Let me name it 1, the given equation. We are now ready to have the equation whose roots are 3 alpha plus 2, 3 beta plus 2 and 3 gamma plus 2. 3 gamma plus 2. Right. Let me write let y is equal to 3 alpha plus 2. From this, alpha is equal to y minus 2 by 3. Got it? Y is equal to 3 alpha plus 2, therefore alpha is equal to y minus 2 by 3. But alpha is a root of 1, isn't it? But alpha is a root of the given equation. So what happens? Implies 9 alpha cube minus 7 alpha plus 6 is equal to 0. Implies 9 into y minus 2 by 3 whole cube minus 7 into y minus 2 by 3 plus 6 is equal to 0. Implies 9 into y minus 2 whole cube by 27 minus 7y by 3 plus 14 by 3 plus 6 is equal to 0. Well, 9 into this is 27, multiplied throughout with 3, this is nothing but 3. Multiply with 3, what is going to happen? Y minus 2 whole cube minus 7y plus 14 plus 18 is equal to 0. What is y minus 2 whole cube? What is y minus 2 whole cube? Y cube minus 8 minus 3 into y into 2 into y minus 2 minus 7y plus 32 is equal to 0. 14 plus 18 is 32. Y cube minus 6 into y minus 6y square minus 6 into y, 6y into y, 6y square again minus 6y into minus 2 plus 12y minus 7y. 32 minus 8. What is 32 minus 8? 24 is equal to 0. Again, let me simplify it. Y cube minus 6y square, 12y minus 7y plus 5y plus 24 is equal to 0. Therefore, the equation with the roots, which one of the roots has 3 alpha plus 2? The other roots will be 3 beta plus 2, 3 gamma plus 2. With roots 3 alpha plus 2, 3 beta plus 2, 3 gamma plus 2 is x cube minus 6x square plus 5x plus 24 is equal to 0. Now, You compare this with the new equation which he has given, x cube plus ax square plus bx plus c is equal to 0. With this comparison, you will be able to have a is equal to minus 6, b is equal to 5, c is equal to 24. 24. A is minus 6, so the first option is wrong. B is equal to 5 we have got, there b is equal to minus 5 is there, therefore the second option is also wrong. In the third option, option C, c is equal to 24, we have got the same answer, option C is right. One more thing, a plus b plus c, what is that? 24 plus 5 is 29, 29 minus 6 is 23, therefore a plus b plus c is equal to 23 is also correct. A plus b plus c is equal to 23 is also correct. So what are the correct items in the available options? C is equal to 24 is correct and a plus b plus c is equal to 23 is correct. The two correct things we have observed among the options are option C and option D. What are the right options? Option C and option D.